Hello and welcome back to my tutorials on Blitz Basic. Right, where we left off, we were explaining the while loop and the if and key hit. Now, there's the easier way to put this. You don't have to set up all this just to end a program. Using the same idea, the key hit, we can actually reverse the effects of the while loop and make it whatever here is not true, then it'll end the loop. So while not key hit, and we'll put the escape key here. Close it. Since we didn't define what the escape key variable was, we were defining it. So remember, you go to the home button or help, command reference, scan code interactive, push escape key. Automatically I remember it's 1 because escape is one of the most common scan codes used to end a program or anywhere in the program, maybe to hit a menu or something. So escape equals 1. Once again, you can easily just put a 1 in here if you choose, but I like to use words so I know exactly what makes my program work. So let's even put a comment here. This is the main loop. So this is where everything's going to go inside that we want to work. Everything outside is not going to keep on looping. It's only going to read it once. Another thing we better introduce is the constants. Just like that. Alright, see, there's different types of variables. The normal white one is just a normal white variable. There's also globals and locals. This is a constant variable. Constant variable mainly means that it'll always remain this number. There's no way you can change it. And if by mistake anywhere in the program you make escape, for instance, equal anything other than 1, so escape equals escape plus 1, the program is going to stop you from doing that. So if I run it, well, actually, there you go. Constants cannot be assigned to. And there's my example on that. So you usually want to put that for numbers that or variables that will always remain that same number. So spacebar, you always want to remain 57, because if you change this to a 2 and the player has no idea that it changed to 2, how are you going to know how to escape the program? 2, the scan code 2 is actually 1, so in order to escape the program you would have to push the 1 button. Let's bring on this real quick and run this. If we push the escape button, it'll end the program. Alright, so now we have a better understanding of the key hit and also not, which basically reverses things. It's pretty self-explanatory because not means do not do that and whatnot. Same thing in coding. Alright, now next thing we want to do is draw something onto the screen, because right now we have a black screen. So let's put some text on. In order to put text, it's quite simple. Text. That's all you need to do. And then you also want to plot your point. So the point we're going to be using is 100 by 200. That way it shows up on everyone's screen, no matter what the resolution is. There you go. Unless the resolution is actually smaller than 100 by 200, but I'm pretty sure it'd be pretty big. There. Putting a little X will appear. Now, I'm not sure if you caught that, but when I first ran the program, there was nothing there. Then it drew it onto there. In order to flip it a little faster than having the computer do it on its own, you want the computer to flip it right away, using the flip command. There's several different uses for this. What the flip command does is basically like my flipbook demonstration. The flipbook's not going to flip itself. You need to flip it with your hands. Now, if you tell the laptop or the computer, the compiler in this case, to flip whatever you want drawn onto the screen, the compiler will do it right for you and right there and then. If you do not have the flip command and you're putting images on, the images won't even show. That's why you need this flip command. Alright, another thing I also want to explain is how the coordinate system in this compiler or even programming works. So 100 by 200 is actually the coordinate right there. The first one is actually the x coordinate, the next one's the y coordinate. I'm going to actually demonstrate this through a picture. Let's go to paint. Alright, let's draw a couple of lines. Now in high school, now you even think middle school, I remember them teaching you that graphs look similar to this. Pencil. And they're endless in all directions. Right here, this would be a positive and positive. Let's say that's 10 by 5. Right here is the x-axis, and up here is the y-axis. As you go up, the y gets positive and the numbers get bigger. As you go down, the numbers get smaller and they become negative. As you go to the right in the x-axis, the numbers become positive and they get bigger. Here, the numbers get negative if you go to the left. However, that's half true in programming. in programming, the graph looks something like this. Okay, I'm having trouble. There we go. Let's just do some lines. Alright. The same thing. This is the x-axis, and this is the y-axis. Right here. As you go to the right x-axis, points get bigger and they're positive. As you go down, instead of getting negative, the points are actually positive and they get bigger. Now, imagine that this is the screen itself. Anything off screen will not show. So anything that's right here, which is actually a positive y but negative x, will not be off screen. Anything that's negative on the graph will not show if the x is negative or the y. So right here is 0, center right here, and this is the edges of your screen, and same with here. However, anything that's off screen but inside this box or beyond this box will remain positive. But if it's beyond resolution, so in this case my resolution is 1000 by 600, if I make any of the points bigger than this, it will not show on the screen. Alright, I know this doesn't mean anything, it's a bunch of scribbles, but I hope that kind of cleared up how graphs work in a program. Alright, now let's put variables to a newer extent. Make that x and a y. Alright, what does x and y mean? It's basically the x coordinate and the y coordinate. Since we didn't make it equal anything earlier, they're both 0. But let's make them equal something. We can change that right away. X will equal 100 and y will equal 200. There. Now if we run the program, it will remain the same. And as I said before, the x appears a lot faster thanks to the flip command. Another way to make things a lot faster and smoother, I don't believe you have to do this for Blitz Plus or Blitz Basic, but it's a good habit to do, is set the back buffer. So set buffer, I mean. The back buffer. Now this is a little more difficult to use when we're not doing images, but explain. But basically what you're doing is you're making the computer draw off screen so it's prepared to flip the next image. Without pointing this, the computer by default is actually drawing to the front screen. That makes it really slow. So if you're doing some type of animation, it'll actually make the program really, really laggy. I'll demonstrate that later. Right now, let's make this x coordinate or this x text point move. So let's do an if statement. If key hit. Now before we move on, we need to find some more constants. We want the left, right, up, and down arrow keys. Now you could still have constants in the same line, you just need to separate them with commas. Go back to the home button, command reference, scan code, interactive. Now you can choose all these and put them all down with different variable constant names. So right key, and I believe I remember all of them. So 205, left key is 208, up key I believe is 200, and down key. You don't have to remember all these, because remember you can always use the scan code interactive picker. That makes things a lot easier. Now you don't even need to name these same things as I do. You can name this whatever you want. You can just name it up. You can't just name this right because it becomes a command. Right will turn blue and it won't work that way. You need to have something in front of it. Yep. Alright, there we go. Alright, thanks to that we can then put right key as one of the scan code, not just right key, as one of the scan codes right there, and make it do something. In this case, we're going to actually add to x. Since the loop is not flipping these variables right here, we can change it. If we put the x inside the loop, it'll continually equal 100 no matter what we do to it, because it'll keep on looping that x to 100. Now in order to add to a variable that's already been defined, x equals itself plus a number. So we're going to do x equals x plus 5. Now running it, you'll see a nice kind of movement going on. Now there's two things I want to change. For one, there's a streak going on. I purposely did that so I can demonstrate that. What it's doing is basically drawing to an image that's already there, or to the screen that's already there. In order to demonstrate this, imagine an artist is creating a flip book where each of the frames are transparent. So if you draw a stick figure moving to the right, like we're doing right now, Flipbook is flipping onto these transparent frames. What's happening is you can see the last frame. So as you see him moving, it ends up becoming a blur in his feet. You see his last foot positions moving combined with the new ones, and he's moving to the right. So it leaves a streak, as it just showed. In order to do that, we want to clear the screen after each frame. And that's basically how this works, is the computer is drawing onto another transparent frame and combining it, making that kind of streak-like effect. Clear screen is just CLS, which is short for clear screen. Another thing is to make the player move faster, we want to change hit to down. That way, as long as the user holds down to the button, in this case the right key arrow, this will remain true, and the computer will read the if statement, adding 5 and moving this text right here over to the right, adding to X axis. So we'll move. See? Nice move. Now, remember, like I said before, if we get rid of this right here by commenting it out, look what happens. It skips frames. Why? Because the computer is quickly trying to draw the next frame onto the screen. And while it's doing that, this is still adding to X. So when it finally gets a chance to put the next frame on top of the screen, this probably already equals more than just 10. I mean 110, 105 or whatever it's supposed to add. So putting that back on, you see a much smoother movement. There we go. Now let's move the X back to the left. This is very easy, actually. You're doing the same thing you did here, except for making key down activate the left key arrow, and you're actually X equals itself minus 5. There you go. Now to show this, demonstrate this with this right here. There we go. See? Pretty interesting. And it's nice, smooth movement. Alright. Cool. Now one last thing I want to do with variables before I end this tutorial and move on to images. The next one is, let's put a new use to variables. See how there's 2 5s right here? Say it's going too fast for you. You want to make those 3s. Instead of having to change every single 5, because in case you put up key y plus y, or y equals y plus 5, you could just set it once, or declare it once. Speed equals 3 in this case. That way you don't have to go throughout your code and look for all the same, look for all the movement variables and having to change all the 5s to 3s. You can just change it once, so I can make this whatever I want. I can make it 10, and it will actually affect both of these. Now it goes really fast. One last thing we need to go over is what happens if I move this into the loop. Now it's going to keep on looping that. Now no matter how fast I make that player go, he will not move. Show that with this right here. I'm clearly pushing these buttons right now. I'll even click on here to show. And nothing's happening. The reason why that's happening is because I have to continually move. So remember how computers read things. It starts from the top to the bottom. Once it hits this point, it's going to start right back to the top. It's not going to read backwards. It's going to start from here, move on to here, to here, to here, to here, here. See if these are true. If they're not true, it's going to skip them. Not even read whatever's inside here. Flip the image onto the screen, end it, and go back up to the top. Now, and once it does that, it's clearing the screen, and then remembering, oh yeah, it's right. X still equals 100. So even if you do add the speed, which is 10, to X, it's still going to continually equal 100. So you want to put that outside the loop. That's why we define all variables you don't want to remain the same throughout the game before the loop. There you go. I hope you enjoyed this tutorial, and in the next one we'll be going over loading, drawing image, and even moving images. Thank you.